Okay, this is part 2 of our section on ANOVA. Here we're going to show you what the ANOVA table, how it works. So at least one time in your life you should calculate an ANOVA table by yourself. Once you've done that, it's okay to use a computer the rest of the time. Okay, so this is that one time. We're going to go through it. So I've made a spreadsheet to help you with this because that's going to be better. Just the calculations you have to do are much better with the spreadsheet than with the calculator. So I've got the spreadsheet I'm going to give to you. It has all the data on the left there, and then it's calculated sample sizes for the total and the groups, and it's calculated the average and the average for the groups, and it's calculated the standard deviation for the total and for the groups. Now I'm going to change my data a little bit just by deleting some. Okay, so now my data is different. I have some missing chunks. So all my formulas are going to be ones that you want to do too, but you're going to so the formulas you want to follow, but my numbers will not be right. So you're going to want to also do these formulas. Okay, so for yours, I'm going to give you this with all the data correct, and you'll need to make a copy of it. You won't be able to edit it. Okay, so you make a copy of it with File, make a copy, then you have something you can edit, and then you can go to town putting in these formulas. So what we want to do here is, I think I can zoom in a little bit. That might be better because I don't care about that data stuff now. Okay, so hopefully you can see okay on your screen. So now, first for part A of this equation, of this problem, you're going to fill in basically those numbers. Like, give me that table. All right, then so for part B, add another row that calculates xi bar minus x bar. So that's basically, this is the average of the groups, of each group, and that's the average total, okay? So we're doing equals to make it a formula. Then we'll need parentheses, and then we're doing the group average minus the total average. Then we're going to press F4, press F4, and then caret 2 means squared. Okay, so I'm going to do that, and I'm not going to do that, but I am going to go to the bottom right and then drag it over. And there we go. We get, that's xi bar minus x bar squared. Okay. So we're calculating the difference between each group means and the total mean, and then squaring those four numbers. Okay. So then we're going to take another row, and we're going to multiply those numbers by the sample size of each group. So now I'm going to the squared error is going to be equal to that number we just calculated times the sample size for each group. And I'm going to take that and drag it over. And there we go. Okay. So then I would write down these numbers. Now for part D, write down something you notice, i.e. a statement, or something you wonder, i.e. a question about the squared error row you calculated above. So these numbers right here, try to either tell me something you notice about what it might mean, or what's big or what's small, or try to ask me a question of, and not just like a what's going on, but something specific, a specific question. Okay? Now, for number 12. So now we'll use the squared error terms from the last exercise to complete the ANOVA table. Okay, so first we'll fill in the DF column. So my first number here will be the same as yours. So DF stands for degrees of freedom. So for model, degrees of freedom, and model, so degrees of freedom, model, that is equal to the number of groups minus 1. Okay, so that's easy enough. And then for the last entry, we're doing So this one, degrees of freedom and total, that's going to equal the total sample size minus 1. Okay? And then finally, for the error, that's going to equal your big degrees of freedom minus your little degrees of freedom. So remember, you put the equal sign in order to make it a formula. So then, there you go. You will have the same 3 that I do because we both have 4 groups, but these numbers will be different for you than for me. Okay, that's our answer to part A. Now we're going to fill in this column for part B, the sum squared error. For the first number, the model row, compute the sum of the 4 squared error numbers from the last exercise. Okay, so squared error, now we're doing sum of squared errors. So it's just the sum equals the sum of, and then you can just highlight these for an end parenthesis and press enter. And there we go. Okay. For the last number, the total row, compute standard deviation squared times n. So for this number, we're doing equals, and we're doing the total standard deviation squared times the total sample size equals. And the same as last time, the error number is going to be equal to the big number minus the little number. Okay. So then that answers part B. So just like in part A, this number plus that number should now equal that number. Okay. So now we're going to fill in this column for part C. We fill in the MS or MSE column. So the mean squared error. For the model, and here you take the, so for both numbers it'll be equals sum squared error divided by degrees of freedom. And I will take that suggestion, but then delete this. Okay. Oh, now my pretty little line is gone too. Yeah, so I'll just go down to the bottom right and drag it down. Okay, so notice that now, since I dragged it down, this one's equal to that sum squared error divided by degrees of freedom. Okay, leave the bottom cell empty. There's no mean squared error for total. Okay, now we're just doing model and error. Okay, it gets easier from here in a way. All right, so then we're going to compute f. F is just the last, so f is going to be equal to the mean squared error of the model divided by the mean squared error of error. And that gives us the F statistic. Okay. Now, here, so that's how you compute the F statistic. Okay. Now, the p-value is a more complicated thing. So, I mean, the way to do it is just like to equals f dot dist dot right tail, and then put in this guy, and then I think you need to put in the other the two degrees of freedom, maybe this and this. I might have them in the wrong order. Let's see if it gives me an error. Yeah, so that looks about reasonable. All right, and then r squared is for part F, so you don't have to do the p-value one because that's just the calculation's too complex. The computer is always going to give that to you, but you should at least try to understand what F is, how we got it, okay? Sort of. I mean, it's a little bit of a complicated process, but you should at least see how it's done once. All right, now we're going to compute the r squared number. So we just need to, the first and last numbers of the SS column. So if we just, this is just equal to this number divided by this number. Okay. There we go. Now you just calculated the ANOVA table, kind of by hand, by spreadsheet. So Another way to think of R squared is the proportion of the variation on the response variable, which is explained by the treatment groups. So we have a small p-value, which means we have strong evidence the alternative hypothesis is true. However, this number is only about 0.03, so you can even, if you want, you can change your R squared to percent. So it's like roughly 3%. I'm gonna take that away. Change it back to a number. Yeah. That means that even though there's evidence that the diets are, well, let me say it for my numbers, and it might be true for yours, it might not be. No, I'm jumping the gun. I just want to keep giving you the answer, and I need to not give you the answer. All right. So R squared is a proportion of the variability in BMI values that can be explained by diet type. Is the percentage of variation in BMI explained high, close to 100%, or low, close to 0%? That should be an easy one once you see what it is. How much variability in BMI is left over? Not explained. So what's 100% minus 3%? Okay? Or your number might be different. Okay. So even though we found our F statistic to be statistically significant, what implications does our R squared have for interpreting our conclusions about the impact of the diets? So just because we can know that diets are different doesn't mean they make that much of a difference. And so try to use that sort of language, use full sentences for that problem. Okay, that completes part 2 of this section.